Now we're going to look at some piecewise functions that are word problems. So Alani has a summer job as a lifeguard. She makes 8 hours for up to 40 hours each week. If she works more than 40 hours, she makes 1.5 times her hourly pay, or $12. For each hour over 40 hours. How could you make a graph and write a function that shows Alani's weekly earnings based on the number of hours she works? So first we have to make a table. So I want to show you where these numbers are coming from. So let's just say we have 20 hours. So I'm just picking a random number. So she's working part-time. Well, 20 times that $8 an hour is equal to 160. Let's say she worked 25 hours times her $8 an hour, which is equal to 200. Her 30 hours times 8 hours is going to give 240. 35 times $8 an hour is going to give us 280, and 40, sorry, I don't know why it keeps on doing that, times $8 an hour is going to give us 320. Now the problem said that as soon as she works over 40 hours a week, she's going to make $12. But remember, for that first 40 hours, she makes $8. So that means that to come up with the 45, she has 40 hours at $8. And then her extra 5 hours, she's making $12. If you multiply those together and add them, she gets 380. For 50 hours, so let's say she works 10 hours overtime. So remember, for the first 40, she makes $8. Then for the next 10, she makes $12. Together, that's our Y value of 440. And the last one, for the first 40, she makes $8. And for the last 15, she makes $12. And that's how we get the 500. So if we plot these, notice I connected it at 0, 0. That's because if she isn't working, then she's not making any money. And I just started at 20. You could have started at 10 or a different number, but I didn't want to make too many points. So notice that we have a line here that goes up to 40, and then the slope of that line changes once we go greater than 40, and that's because we're multiplying those extra hours by 12. So here, notice that the plot contains 2 linear segments with a slope that changes slightly at x is equal to 40. A function that has a different rule for different parts of the domain is an example of the piecewise. So it's one situation, so we want to put it together on one graph, but yet there are actually 2 different functions happening in this one situation. Now we want to actually write an equation, so a piecewise equation. So our domains, let's start with that. Our domains are the number of hours worked. So remember, domain is our x value, and our x value in this case is hours worked. So depending on how many hours worked, she made a certain amount of money. So our first domain would be she worked no hours up to and including 40. So she made $8 for each hour worked. And then after that, so after 40 hours, yes, we don't know how much she's going to work, so I'm going to say after 40, she's making a different rate. So our two different domains are up into and including 40 and then after 40. Now, what are the equations? So if we look back, our equation for the first 40 was the number of hours times 8. Notice that we multiplied every single hour that we picked times 8. So let's go and actually make that as an equation. So 8 times x, because we already identified x as our number of hours worked. Now if we go back again, for our hours after 40, notice how the first part of this is all the same. So that's going to be part of our equation, the 40 times 8 plus, and then we had the number of hours that were greater than 40 multiplied by 12. So this is going to look a little bit tricky. So I'm going to write this out down below and then we'll simplify it and put it into our equation. So when x is greater than 40, she would make $8 times those 40 hours. That's a given. But then she's going to make $12 times any hour that's greater than 40. So let's just say our example is 45 hours. So really we want this to be a 5 in here, not a 45, because that would give us an inflated amount of money. So if, for example, we're talking about 45 hours, what we're going to do is we're going to say that we're going to put our x and then we're going to subtract 40. And that's because that first 40 has already been accounted for in this first part of the equation, 8 times 40. So look at it this way. If we practice our example and see if this works. If we take 45 and we enter it into the equation and then simplify, we would get 45 minus 40, which would give us that extra 5 hours. And only the extra 5 hours is what she's making $12 per hour on. So 8 times 40 plus 12 times x, so whatever the total number of hours worked, minus the original 40, because we're already counting that. So then we need to simplify this, because we're not going to write this big long equation in here into our domain function. So when we multiply this together, we get 8 times 40, and that's going to give us 320, plus, when we distribute, we get 12x minus 480, and then when we simplify, 320 minus 480 is negative 160. So we're going to put our simplified equation up here. So our final answer is the piecewise function with the domains attached to it.